Buenos días amigos de Landatel, me llamo Diego García y soy el Product Manager aquí en Landatel de la marca Tycon Systems. Bueno, nosotros en Landatel siempre hemos tenido buena relación con esta empresa desde hace años y si alguna navega un poquito por nuestra tienda habrá podido ver que vendemos estos productos y precisamente gracias a esta relación el CEO de esta empresa, Bruce Sutton, y la persona que nos va a hablar hoy, Seth Allen, que es el encargado de marketing y ventas, vinieron a principios de mayo a hacernos una presentación sobre estos productos, una presentación que nos pareció interesante y un poco hablándolo con ellos, hemos decidido un poquito trasladar todo eso que nos contaron al público para que os lo puedan contar directamente. Para los que no conozcan Tycon Systems, es una empresa estadounidense que gracias a sus dos ramas, Tycon Power y Tycon Wireless, están muy especializados en este mundo. Ahora Seth os lo presentará con más detalle, pero quiero que sepáis y quiero decir personalmente que sus productos destacan mucho por la calidad que tienen gracias a esta especialización. Entonces, hoy nos van a presentar su solución para proveer de energía a aquellos lugares remotos donde no llegan las redes tradicionales de energía y que a las empresas, sobre todo los WISP y proveedores, no se les ocurre como una opción porque no saben que tienen este tipo de soluciones. Entonces, precisamente el mayor problema es que no sabemos lo que la tecnología actual es capaz de darnos. Entonces, Tycon Systems ha conseguido, gracias a esta evolución de la tecnología, proveernos de una solución que sobre todo nos asegura que la calidad de nuestro enlace nunca se verá perjudicada. Hoy Seth no viene a presentarnos un catálogo de productos, hoy Seth viene a enseñarnos un poco cómo planificar estos sistemas para que no tengamos problema por tenerlo dimensionado excesivamente por lo bajo ni a pagar por algo que no necesitemos. O sea, hoy no presentemos enseñaros tampoco a planificar, queremos enseñar un poco qué se puede hacer, qué podéis conseguir y sobre todo lo que queremos deciros es, en el momento que os interese una solución de este estilo, que podéis venir a nosotros para que os ayudemos vamos, que podéis contactar nosotros para cualquier cosa. El plan de hoy será el siguiente. Ahora Seth nos hará su presentación y después de esta presentación abriremos un turno de preguntas. Durante toda la presentación yo os invito a que vayáis escribiendo las preguntas. Aunque la presentación sea en inglés, podéis escribir la pregunta en el idioma que queréis, yo me encargaré de traducírsela. Y al final de todo seleccionaré un par de preguntas, 3 en función del interés y del tiempo, que se las plantearé a Seth. Y todas las preguntas que no lleguen a contestarse durante el webinar, bueno, pues tenemos todos los datos de la persona que está preguntando, así que contestaremos personalmente a todas aquellas preguntas que queden sin contestar. Y por último, si después de este webinar os surgen alguna otra pregunta, podéis contactar con nosotros a través de webinar@landatel.com y bien nosotros desde Landatel o Seth desde Tycon Systems haremos todo lo posible por resolver de la mejor manera posible vuestras dudas. Entonces le voy a pasar el turno a Seth. Good morning, Seth.
Good morning.
I want to thank you for this opportunity. I think I have just said everything I need, so we are all ears. I'll give you the lead.
Okay, great. Thank you so much, Diego. Look forward to this opportunity. Excuse me. So I will share the screen. Let me know when you see that.
We are okay. We are seeing everything okay. So
very good.
We are all ears.
All right, very good. Thank you very much. So a little introduction about Tycon Systems, and I think Diego did a great job explaining. We were founded in 2008. We started as a wireless backhaul option called the Easy Bridge, and this is just a simple point-to-point backhaul application. The radios come pre-configured, and so we started just as a small company about 8 years ago. We developed unique PoE devices, some DC-DC converters, and found many opportunities for that helped the market where there were maybe some holes. We have customizable PoE equipment that and many OEM customers. And then we started looking at remote power through wind and solar. And so that's what we're going to focus on today. We're located in Bluffdale, Utah, about 20 miles south of Salt Lake City. It's a desert here in Utah. However, we do have some beautiful scenery. So we have nice mountains in the background, plenty of trees and greenery, and so don't feel sorry for us that we're in the desert. We love Utah, and we love the outdoors here. So a little bit about remote power. A lot of people ask us, what is remote power? What are the different applications? And so that's what we're going to cover today. Is remote power is a cost-effective solution to be able to bring power to a location where maybe digging trenches or running power lines really isn't an option, or maybe it's not cost-effective. Maybe it's not. Maybe it's too expensive to bring power. So here's a couple of scenarios where we have our applications. Here is a wildlife preserve where there's an osprey nest, a bird that has a nest in the middle of the lake here, and they wanted to observe the migration patterns and the nesting habits. So they have a camera here, but they didn't have a way to get power to that site. We do a lot with construction sites, temporary sites that maybe, for security purposes, they want to make sure that they have cameras up or be able to power some equipment, but it's going to be a temporary site where they're going to move once the construction is done. CCTV for apartment complexes or other facilities. So there's a lot of applications, a lot of opportunities that we see with remote power. For what we call our remote power is our Remote Pro. This is our system that we build. It's a complete kit that includes our solar panels, batteries, enclosures, all of the cabling and mounting hardware that you need. Basically everything to power all of your equipment, all of your devices, minus the pole. You bring the pole and we have all of the gear. We have systems ranging from 5 watts of solar panels up to an array of 280 watts. And we have a 500 watt and 1 kilowatt system coming soon. This is due to release in September. This would be with our ground mount aluminum enclosure, and each panel is 250 watts. So we're excited for this opportunity because more and more applications are becoming larger. So we see a need to develop larger systems. And so today we're going to talk a lot about how to size a specific system, how to, all of our systems are customizable. We customize them so that they can fit each application, because each application will be different. And so what we do, we look at the different variables. We have the total draw of all the devices. So anything that is going to be powered has, is what we consider draw, right? So we look at the draw in watts, and after that we look at the average hours of peak sunlight. We notice that in each location the sunlight is going to be a little bit different, whether you have, you're closer to the equator, so you have more sunlight, or maybe you're close to a body of water and you have more fog or more cloudy days. We look at hours of operation. Is this system going to run 24 hours during the day, or is it going to be 8 hours or 12 hours? And so these are the different variables that we take in consideration when sizing the system. So you can size your system yourself, or you can have one of our technicians, our support team, size the system. To be able to size, you can go to our website at tyconsystems.com, highlight the Resources tab and click on Calculator page. Or on our home page, or once you go to Calculator page, we have a tab that says Request System Design. That's where you can click on and fill out the form, include your equipment that you're going to be powered, your location, and then we can do all of the work for you and be able to size each system specific to your needs. So when you go to Tycon Systems, Resources tab, and then Calculators, you'll have a page like this. This is where you are going to fill in the information to be able to see which system. So we're going to do a little test system today. We're very familiar with Ubiquity equipment. We power a lot of their equipment all over the world. And so I took a little sampling, one of our most common system design requests. So for this, we're going to use the AirFiber 5X. I'm sure that most of you are familiar with it. And we're going to take 4 of their bullet style cameras, the UVC. So with these, we're going to look at each one. So I like to size each system. I like to have our support team do that just so that we make sure that we're reading the data sheets correctly. So we're going to give you a little sample of how to read the data sheets. Ubiquity does a great job of providing all of the information that you need. So let's take this example. So first we're going to look up the air fiber 5X. You can go to Ubiquity, ubnt.com, pull up their data sheet for the air fiber 5X, and then you can see here that your max power consumption is 12 watts. And so I like to make notes. I have a little notepad when I size these systems, and I make sure I write all of this down so I can make sure that we're going to power everything properly. So 12 watts max power consumption, and then we're looking at the voltage requirements. So they come with a 24 volt PoE at 1 amp. So here's the notes that you're going to put: 12 watts max draw and 24 volt PoE. Next, we're going to look at the cameras. I like the Ubiquity cameras. They have a very low draw. Each camera, manufacturer has their own requirements, and so some do a very good job of listing their total draw. Some might get a little confusing because you need to take in consideration whether you're using infrared, so your IR cameras, if there's a heater, if you can disable the heater. In warmer locations, warmer climates, you typically don't need that. And we notice that heaters create a lot of draw, and sometimes unnecessarily. So if you can disable the heater, that's a bonus for you. So here we see that their power consumption is 4.5 watts. And their PoE, 24 volts, same as the air fiber, at 0.5 amps. So this gives us 4.5 watts times 4 cameras, all at 24 volt PoE. So if you're doing the math in your home or in your head or writing it down, so far for these we're at 18 watts for the cameras, another 12 for the air fiber, so we're at a total of 30 watts draw. For this many devices, we need to look at powering, so looking at different switches. We have a wide variety of, as I mentioned, PoE devices along with PoE switches. So here's just an example. This is a very common switch for us, and I hope you enjoy the background. I pulled some pictures of Utah, so as we put some of these pictures up, you'll be able to notice some of the scenery that we have here in our state. So here's our TPSW5G. It's a passive PoE switch, so what you put in, you'll get out. So this can be a 24 volt switch, has a very low draw, and it's a 5-port switch, so you've got your input and then 4 output. So now we're at about a total of 33 watts. So we're going to put that in there in our system calculator. So you'll change the load in watts to 33 watts, and we're going to have this running 24 hours during the day. We want it always up. So now we're going to look at our peak sunlight. As you can see to the right, we have useful links. These are our solar maps, PV watts calculator, where you can put in the postal code or city, state, country, and look at the watts. You do need to change a few of the variables in that, like the latitude of your location, so that we can figure out the tilt, or also the Europe solar data. So we're going to use the Europe solar data so that we can see how much sunlight we need in that area. This is also where you can help size the system. So this is where you could click to say, no, this is too confusing, or I want to have somebody double check. I'm a big fan of that. If you're new to sizing your system, always ask for help, and then confirm with the calculations that you did so that you can become proficient at that. So here's the Europe solar data. We're going to click on that link, and we'll get a new link like this, where you can type in your latitude, longitude, or you can pin the location. So we're going to choose Madrid in Spain. So you can pin it, go ahead and hit calculate, and this will show how much peak sunlight hours you have in your area. So as I mentioned, each location is different, whether it's Madrid, Barcelona, Portugal, Morocco. So any of these locations will have different sunlight hours. Now, to be able to power this equipment year-round, we have to size the system based on the lowest amount of sunlight. So typically, if you're north of the equator, that would be your December and January months. So we're going to look at December. That's the lowest, at 2.85 peak sunlight hours each day. We know that if we power in December, they're going to be able to power throughout the year. All of our systems are designed so that they are powered 365 days. We don't want any downtime. So we're going to take that number, 2.85, and we're going to change it and into the average hours of peak sunlight. So you notice now we have 33 watts, 24 hours a day, 2.85 hours of peak sunlight, and then you have the next is the extra batteries of backup. I usually don't change that. I leave that at 0 so that I can see exactly how much battery backup and battery bank and solar panel size we need. So go ahead and hit calculate, and let's see. I guess I talked too quickly, so hit calculate, and then you can see at the bottom, for this system, you will need a minimum of 278 watts of solar panels, 117 amp hours of battery backup, and then we also recommend several systems that you could use. So we have our RPST 24XX, so that means it can be either 24 volt PoE or 48 volt PoE. And then the rest of the part number would be 100, which is our amp hour battery backup, our battery bank. So it's 24 volt battery bank, 100 amp hours. So you'd actually have 4 50 amp hour batteries or 200 amp hours. And then 280 is our solar panel array that would come with this. The picture to the right would be the system. Those are 70 watt panels. Times 4 would be your 280 watts of solar. This would come with our steel enclosure, be able to hold your battery bank inside the enclosure along with your charge controller, your switch, and other small devices that you may need for that. Notice that your minimum size solar panel needed will be 278 watts, and this comes with a 280 watt array. So it's very close to meeting the minimum requirement. For applications like this, or when you're worried maybe for extra hours of battery backup or needing help to get that extra charge, we have our Breeze Pro, which is our wind turbine. This system can be added, or this wind turbine can be added to any solar system. It's all solar ready. It has a built-in and integrated charge controller with a dump load, so you avoid overcharging the batteries. It has a very low startup wind speed. The startup wind speed is only 2.1 meters per second, and that way you can already begin to charge your batteries when you have cloudy weather or when the sun goes down. So this will help supplement your solar system. When added, we consider this our hybrid system. So you can use your wind with solar. With this, we also, it has an electronic overspeed protection, so it will prevent overspeed in high winds or with extreme wind bursts. And this will charge and power, it'll provide 300 watts at 12.5 meters per second wind speed, so, and up to 400 watts of power generation. So it's a very small, it's only about 1 meter in diameter, but a very powerful wind turbine and very durable to help supplement when you have lack of sunlight. So next would be how to set up the system. So we've decided, we figured out how much solar we need. The next challenge is how are we going to power each device? With this, it was very simple. Everything was 24 volts PoE, but you may have different applications where you have a 12 volt DC LED light, or a 12 volt DC camera, or 48 volt PoE. And so the first step would be to size the system, and then the next is how you're going to power each device. So here we have our charge controller in the middle. This is what would come with this system, and we'll show, we've got a little picture on top of the back, so we have our wire terminal on the back. So we're going to first connect our solar panels into the wire terminals there. Again, all of the cables are provided to connect everything. Next, you set up your battery bank. This will be wired at 24 volts. We have a installation guide that we provide with each system so that you'll know whether you need to wire your batteries at 12 volts or 24 volts. Next, we're going to connect our charge controller. We're going to put, our switch. So we're going to do the uplink into the input of the charge controller so that your data can flow through. And now we're going to power through the wire terminals on the back of the controller. Next, we're going to set up our access point. The top port is our PoE output. That can be 24 volt or 48 volt. We're excited to announce that we have a 4-port charge controller due to release this year. So this way you can add extra devices to your system and it will have a higher availability for current. But here we're going to connect our Air Fiber 5X to the input, and then all of our cameras will be powered from that switch. So you can run just one cable to each, or we have a PoE extender that can add an extra PoE port so that you can run one cable instead of two. So this would be your typical application, your typical setup. Your controller and your switch would be in your enclosure along with your batteries. Your solar panels mounted above the enclosure, and then you can run your cables and mount your cameras and backhaul radio to wherever you need. And all of the cables, we have the cable glands at the bottom of the enclosure, so all of these can be connected and run directly through. So next, we've talked remote power through solar. We also have just battery backup. Maybe you have power, but you don't have consistent power, or maybe power goes out for certain times of days, or you just need a dedicated battery backup. You have power, but you have that backhaul that if it goes down, you're in trouble. So we have our UPS Pro, which is just our battery backup. Very simple to calculate. Again, you take your load in watts. Let's use the same example as the system that we have that we've done with solar. So we're going to take 33 watts of your total load. We're going to change the battery backup. Let's say that you want a minimum of 8 hours of battery backup. That will give you time to go out, fix any power outage you have, or maybe connect a generator, or whatever you need to do. And all of our UPS systems are solar ready as well. So if you start with a UPS system and then realize, maybe we're going to be out of power for a longer period of time, you can add solar to each of our UPS systems to be able to power your devices. So again, just hit calculate. And now we can see exactly what system we would need, the UPS ST 12-50. This would provide 50 amp hours of battery backup. So you're able to power all of your devices for over 8 hours. And then this would be the system that you receive, again with the steel enclosure, batteries, your charge controller, and all of the cables and mounting hardware that you need. Many people add this to their systems as well. Our power monitoring. We developed on the left hand side is our battery meter, so you can connect to see what your voltage is that you're receiving from your batteries. On the right, we're excited with our power sends. This is our TP-DIN monitor. You can connect these to any system, and they're not exclusive to solar or UPS. We find many people use our TP-DIN monitor in so many different applications where they need to set up relays. So this allows you to set up to 4 relays. You can measure voltages, current sensors, temperature sensors. It has an internal and an external temperature sensor, and then also allows for auto control relays. So you can set up a ping or a watch for when the voltage drops, or if your temperature drops or increases or rises to a certain temperature, you can receive an email to say that, to notify you if there's an issue. And so you can log in remotely through your remote location, or log in through your laptop and be able to set up a reboot for your radio, so you don't have to drive out to that remote location. You can just log in remotely, whether it's on your cell phone or your laptop or your desktop computer, and be able to access via web or SNMP. You set up your auto email alerts. It has an onboard data logger, and you can just mount directly to the DIN rail so it can stay in your enclosure, and you can connect all the wires directly. So these are recommended for each system. As you have remote locations, you probably don't want to go out to each of these sites. So I'm going to show you a couple of different applications that we have all over the world, with whether it's with our solar or battery backup or with our TP DIN monitor. So our first is a little extreme. I don't think that you have to worry too much about this in Spain with the snow, but this is in the Arctic. These scientists set up our solar system, and in that provided that pelican case to house all of their equipment, because it does get so cold. And they set up cameras for a polar bear migration watch. They're able to watch the migration of the polar bears, see as they, as they're mating and migrating through the year. So kind of an extreme environment, but very successful for them. This we just, and we're always looking at case studies, so if you have an application, we love to use it in a case study and show what you have done. It's exciting to us to hear about it. This is a farmer in Texas, and he has a problem with pigs. I guess there are a lot of wild pigs in the area, and so he set up traps, but they're not very efficient. So he developed this fence, but needed some sort of system to be able to let him know when there were pigs in the area. And so he was able to set up the solar system with our TP DIN monitor. It sends him a ping when he has enough pigs in the pen, and he is able to close the gate and trap them, and then do his thing with the pigs. And won't go too much into much more of that, but it's been very successful for him to be able to control his the wild animals in his area. Here's another environment. It gets extremely cold, but they set up a telephone in this area, so hikers or people that need it in an emergency are able to call. Now I think this one is actually on a golf course, and so after 9 holes of golf, they can call into the clubhouse and order their lunch. But this is just a small system. It doesn't have a lot of draw, but it has been very convenient. It would have been very expensive to run power, out to this remote location. So this has been a very common one. Just small draw, small system. This has been very. We've seen a lot more applications come up with LED lighting. They could run power very easily. You can see a power line on the other side of the road. However, the cost to dig through that and trench through that concrete would have been extremely expensive. And they just wanted to run 2 LED lights. I believe they have about an 8-watt draw each. So they were able to power it, from dusk to dawn, power the lights, be able to light up the sign in the evening and during the night, so that people could see, when they were entering the city. Again, just a small solar system, very inexpensive solution to be able to power your lights. This is a water treatment facility. They're able to communicate with just a Ubiquiti nano station back to the central station that's just about 2 kilometers away. Again, they could run power, but at a very extreme cost. And so they had some issues at this water treatment facility with vandalism, people breaking in, or vandalizing the different equipment, or writing on their things. So they were able to set up these cameras to avoid the vandalism, and they've had success with avoiding that. So Another great opportunity, whether it's in a parking lot or in a field, a park, public parks, to provide either lighting or camera system. Portable solar, we have one of our customers down in San Diego, California, that needed some portable solar for his different construction sites. So he developed these trailers. He has his equipment on the inside, his NVR and everything, and then set up his cameras so he's able to go record, set up the solar so he can just drop the trailer, leave it for a few days or weeks at a time, and it's able to power all of his equipment. So again, they'll have power, they could run generators, but the cost to do that is not very efficient. This is another extreme. This is the top of a mountain in Idaho, just our neighbor to the north. This is at 7,000 feet elevation. This is a couple of backhaul radios that they're able to connect from mountaintop to mountaintop, and they needed a system to be able to power these. So they've got our solar panel array with our steel enclosure to protect the equipment, and they're able to power those two radios. Look like ubiquity nano beams. So been very successful to them. Now with this is what's different about this type of scenario is there's a lot of snow in the winter time, so you can only get up through snowmobiles or through four-wheelers. So this isn't something where you could just drive up on a road and take care of something. So they needed something that was durable, that would be able to power these devices year-round. Here's another backhaul link that's at the top of a mountain. You can see a lake in the background, and so this has been a very good system for them as well to be able to power this device going from mountaintop to mountaintop. So you see a common theme. A lot of these are in remote locations where they don't have the ability to run the power, or it would just be so expensive to do so. And then here's your complex lighting system. They have this in a parking lot, and they wanted to light it up at night to be able to provide security to the people that are in that area. So been very successful with this, and so we see these applications and talk to people so frequently, and it encourages us to keep improving and keep developing more and more productive ways to power equipment. So we see with water pumps with irrigation, or RFID scanners with cattle and cattle ranches. We do a lot with the agriculture industry. Security is a continuing industry that we see increasing constantly, and so whether it's with lighting or security cameras, we're always looking for these opportunities. And we've had many customers come to us when we talk to them and say, I've had many of these opportunities come up, but I had to turn them away because I didn't have a way to power. And we've seen this solve a lot of solutions for our customers. To make life more simple, we have an app that you can download. It's available for free through Google Play or through the Apple Store. You can download and have access to our Remote Pro Calculator, our UPS Pro Calculator, find out the solar panel tilt for your area, and then also you can set up all of your TP-DIN monitors, all of your power monitoring. Has a device discovery, so you can have all of them, name them separately, so that you can go in, log in, and check to make sure everything's working smoothly, correctly. You can set up your reboot for a camera or radio, so you don't have to drive out to the location. So we're excited to have this app available for our customers, and we're always looking to improve. So as you have these system applications, or as you have I didn't spend a lot of time on PoE devices, on DC to DC converters, but we have a wide array. But I knew that you all have some football matches to get to, so I didn't want to take up too much time, because we could go on for a long time talking about the unique PoE devices that we have available. But we're excited for that. So if you see any applications or any opportunities, please contact Landatel, and they can get in touch with us, and that way we can make sure that you're you're supported with that. So we will now open the time. As you can see, this beautiful. I don't know if you're familiar with Moab, but we have the arches, and so this is the last screen that we wanted to show with you and ask if there were any questions. So Diego, I'll turn it over to you to be able to review any questions that there may be.
Thank you, Seth. By the way, nice scenery. Utah is really, really nice. First of all, I want to. We have a few questions about durability of your system. How about lifespan of the solar panels, the lifespan of batteries? Can you tell us something about the quality of these batteries? I don't know.
Absolutely. Yes, thank you for that. For our batteries, we have 5-year batteries, so we have great success with them. Obviously, it depends on the amount of discharge used, but typically we see them lasting about 5 years, and we are always looking at new technology to improve our battery system. Typically, you have a couple of variables for the batteries. But you can, whether it's the amount of charging or the deep cycle batteries. What's interesting about these systems is if you need, you can actually purchase the batteries locally if you have another source. These batteries are lead acid batteries, so you can find them typically locally and save on the expense of shipping. Or with Landatel stocking these batteries, it will also help to save on the shipping costs. So whatever you prefer on that, but they are 5-year batteries. Our solar panels are 25-year solar panels. They have been tested and retested to confirm that they have a lifespan of 25 years, so you will not see any degradation or loss of charging with these panels after a couple of years. We've seen some of the some other brands, other models, that after 3 to 4 years they start losing their ability to charge as quickly. But we've seen with these that they last 25 years. We use the crystals. The technology was developed in Germany. So those are the types of solar panels that we use, and we stand behind those solar panels.
Okay, thank you. Other question, again related with batteries. Is there any problem with overcharging or heating?
No, with the dump load that we have through these wind turbine and with the charge controller that we use, it prevents overcharging. So once the batteries have received its full charge, then the controller prevents it from overcharging the battery. So you don't have to worry about that. Or with the heat, we've had these in extreme temperatures. Now to prevent overheating with just equipment and everything in the enclosure, we have a power vent that we add to the bottom of the enclosure to prevent overheating. So it has 2 fans, one to draw in fresh air and another to blow out. So that prevents from overheating inside the enclosure. But no, we have not had any issues with overheating or overcharging with our batteries because of our controllers and the technology with that.
I understand that this controller will also protect our equipment.
Yes, absolutely. So all of our PoE devices and DC converters are surge protected, and so the controller will protect the equipment and be able to power them continuously. There's no lapse. So if you have a UPS system where you have power, and the power goes out, there's no handoff. It's an immediate continuation of power. So it's an uninterrupted. So.
Okay, thanks. We have further question, but the last I will ask you. How is this physically, this equipment? Have we any restriction when we want to implement it? Weight, height?
That's a great question. So we typically recommend the solar panels to be a minimum of 10 to 12 feet. And I apologize, I guess I can do an easy conversion. So about 3 meters minimum height, and then as high as you need to be able to, be over buildings or trees, foliage, anything like that. So obviously you want to have it in the solar panels in direct sunlight, and then we encourage mounting the enclosures higher to prevent vandalism. There's a lock on the enclosure, but you know, if people have tools, then a lot of times they can pry them open. But we really haven't had many issues with vandalism when they've been mounted at least 3 to 4 meters in the air. But there's no restriction on height. If you had them, as you saw, we had several of them, 5 to 10 meters in the air. So there's no restriction on that. With the wind turbine, obviously you want to get as high as possible where you will have the wind. Typically you don't have as much wind at 3 meters that you'd have at 10 meters. So there is no restriction, but the higher the better, just to be able to get past any foliage, to get in the way of the wind. You want that. So as long as you have sunlight and direct sunlight, then you're in good shape.
About weight, does the battery bank is really heavy?
Yes.
Or is
it is? It is heavy, and so you want to make sure with these the mounting hard that we provide would get you typically it's up to like a 4-inch pole. So you'd want that about your minimum pole dimensions. Excuse me. The enclosure is heavy. It's a steel enclosure, and it's meant to be heavy duty. Excuse me. And then the batteries are about 30 to 35 pounds each. So you're looking at about 150 to 200 pounds of weight. So you want to make sure that you have a sturdy pole. It's not an issue with wind load or anything like that, as long as your pole is sturdy. But typically with these, you're gonna, when you're taking them up to the pole and you have either your truck with the lift on there, or if you're climbing the tower, then you'll definitely want some help to be able to take up each battery one at a time and wire them, so that you can save your back on the weight of mounting them. But yeah, we haven't had any issues with weight, except if somebody didn't have a strong enough pole. But yeah, all of the mounting hardware is designed to be able to withstand the extra weight of the batteries.
Okay, I think is enough. Thank you, Seth, for everything.
My pleasure.
So I'll see you. I hope we can make another time something like this.
Absolutely.
Bueno, amigos de Landatel, espero que hayáis entendido todo bien. Simplemente un poco de todo lo que ha dicho Seth, me gustaría recalcar que es un sistema que no tiene limitaciones. Como hemos visto en los casos que nos ha presentado Seth, podemos plantear casi cualquier tipo de sistema para casi cualquier tipo de utilidad. Él nos ha hecho el ejemplo con Ubiquiti, pero por la experiencia de cuando nos estuvieron tratando aquí, podemos instalar una gran variedad de marcas y es, como él nos ha dicho, una solución barata y fiable para un poquito casi cualquier sistema que nos podamos plantear. Lo que he dicho al principio, el mayor problema que tenemos es que no sabemos la capacidad que realmente tiene esto. Por eso os invito a que os metáis un poco tanto en la página de Tycon Systems como en nuestra página de Landatel para informaros de verdad qué podéis hacer en un futuro, ¿de acuerdo? Yo creo que esto es todo. Muchas gracias por haber venido, haber participado. Contestaremos a las preguntas que nos habéis planteado y que no hemos podido decir en directo a lo largo del día o la semana. Y lo dicho, muchas gracias por venir y que tengáis un buen día.